Object-oriented programming is a programming paradigm based on the concept of objects, which are data structures that contain data, in the form of fields, often known as attributes, and code, in the form of procedures, often known as methods. A distinguishing feature of objects is that an object's procedures can access and often modify the data fields of the object with which they are associated. In OO programming, computer programs are designed by making them out of objects that interact with one another. There is significant diversity in object-oriented programming, but most popular languages are class-based, meaning that objects are instances of classes, which typically also determines their type. Many of the most widely used programming languages are multi-paradigm programming languages that support object-oriented programming to a greater or lesser degree, typically in combination with imperative, procedural programming. Significant object-oriented languages include Python, C++, Objective-C, Smalltalk, Delphi, Java, Swift, C#, Perl, Ruby and PHP. Features: object-oriented programming by definition uses objects, but not all of the associated techniques and structures are supported directly in languages which claim to support OOP. The features listed below are, however, common among languages considered strongly class and object-oriented, with notable exceptions mentioned. Shared with non-OOP predecessor languages, object-oriented programming languages typically share low-level features with high-level procedural programming languages. The fundamental tools that can be used to construct a program include variables, which can store information formatted in a small number of built-in data types like integers and alphanumeric characters. This may include data structures like strings, lists and hash tables that are either built-in or result from combining variables using memory pointers. Procedures, also known as functions, methods, routines, or subroutines, that take input, generate output, and manipulate data. Modern languages include structured programming constructs like loops and conditionals. Modular programming support provides the ability to group procedures into files and modules for organizational purposes. Modules are namespaced so code in one module will not be accidentally confused with the same procedure or variable name in another file or module. Objects and classes. Languages that support object-oriented programming typically use inheritance for code reuse and extensibility in the form of either classes or prototypes. Those that use classes support two main concepts. Classes, the definitions for the data format and available procedures for a given type or class of object, may also contain data and procedures themselves. Objects, instances of classes. Objects sometimes correspond to things found in the real world. For example, a graphics program may have objects such as circle, square, menu. An online shopping system might have objects such as shopping cart, customer, and product. Sometimes objects represent more abstract entities, like an object that represents an open file, or an object which provides the service of translating measurements from US. Customary to metric. Each object is said to be an instance of a particular class. Procedures in object-oriented programming are known as methods. Variables are also known as fields, members, attributes, or properties. This leads to the following terms. Class variables belong to the class as a whole. There is only one copy of each one. Instance variables or attributes, data that belongs to individual objects. Every object has its own copy of each one. Member variables refers to both the class and instance variables that are defined by a particular class. Class methods belong to the class as a whole and have access only to class variables and inputs from the procedure call. Instance methods belong to individual objects, and have access to instance variables for the specific object they are called on, inputs, and class variables. Objects are accessed somewhat like variables with complex internal structure, and in many languages are effectively pointers. serving as actual references to a single instance of said object in memory within a heap or stack. They provide a layer of abstraction which can be used to separate internal from external code. External code can use an object by calling a specific instance method with a certain set of input parameters, read an instance variable, or write to an instance variable. Objects are created by calling a special type of method in the class known as a constructor. A program may create many instances of the same class as it runs, which operate independently. This is an easy way for the same procedures to be used on different sets of data. Object-oriented programming that uses classes is sometimes called class-based programming, while prototype-based programming does not typically use classes. As a result, a significantly different yet analogous terminology is used to define the concepts of object and instance. In some languages, classes and objects can be composed using other concepts like traits and mixins. Dynamic dispatch, message passing. By definition, it is the responsibility of the object, not the external code. 2. On demand. Select the procedural code to run, execute in response to a method call, typically by looking up the method at runtime in a table associated with the object. This feature is known as dynamic dispatch, and distinguishes an object from an abstract data type, which has a fixed implementation of the operations for all instances. If there are multiple methods that might be run for a given name, it is known as multiple dispatch. A method call is also known as message passing. It is conceptualized as a message being passed to the object for dispatch. Encapsulation. If a class disallows calling code from accessing internal object data and forces access through methods only, this is a strong form of abstraction or information hiding known as encapsulation. Some languages let classes enforce access restrictions explicitly, for example denoting internal data with the private keyword and designating methods intended for use by code outside the class with the public keyword. Methods may also be designed public, private, or intermediate levels such as protected. In other languages this is enforced only by convention. This is useful because it prevents the external code from being concerned with the internal workings of an object. This facilitates code refactoring, for example allowing the author of the class to change how objects of that class represent their data internally without changing any external code. It also encourages programmers to put all the code that is concerned with a certain set of data in the same class, which organizes it for easy comprehension by other programmers. Encapsulation is often used as a technique for encouraging decoupling. Composition, inheritance, and delegation. Objects can contain other objects in their instance variables. This is known as object composition. For example, an object in the employee class might contain an object in the address class, in addition to its own instance variables like first_name and position. Object composition is used to represent has-of relationships. Every employee has an address, so every employee object has a place to store an address object. Languages that support classes almost always support inheritance. This allows classes to be arranged in a hierarchy that represents is a type of relationships. For example, class employee might inherit from class person. All the data and methods available to the parent class also appear in the child class with the same names. For example, class person might define variables first_name and last_name with method make_full_name when included in class file reader and class web page scraper, which don't share a common parent. Abstract classes cannot be instantiated into objects. They exist only for the purpose of inheritance into other, concrete, classes which can be instantiated. In Java, the final keyword can be used to prevent a class from being subclassed. The doctrine of composition over inheritance advocates implementing is a type of relationships using composition instead of inheritance. For example, instead of inheriting from class person, class employee could give each employee object an internal person object. which it then has the opportunity to hide from external code even if class person has many public attributes or methods. Some languages, like Go, do not support inheritance at all. The open-closed principle advocates that classes and functions should be open for extension, but closed for modification. Delegation is another language feature that can be used as an alternative to inheritance. Polymorphism subtyping, a form of polymorphism, is when calling code can be agnostic as to whether an object belongs to a parent class or one of its descendants. For example, a function might call make_full_name, typically using a special variable or keyword called this or self. This variable is late-bound. It allows a method defined in one class to invoke another method that is defined later, in some subclass thereof. History. Terminology invoking objects and oriented in the modern sense of object-oriented programming made its first appearance at MIT in the late 1950s and early 1960s. In the environment of the artificial intelligence group, as early as 1960. Object could refer to identified items with properties. Alan Kay was later to cite a detailed understanding of Lisp internals as a strong influence on his thinking in 1966. Another early MIT example was Sketchpad, created by Ivan Sutherland in 1960-61, in the glossary of the 1963 technical report based on his dissertation about Sketchpad. Sutherland defined notions of object and instance, albeit specialized to graphical interaction. Also, an MIT algol version, -0 United Arab Emirates theorems, established a direct link between data structures and procedures, prefiguring what were later termed messages, methods, and member functions. The formal programming concept of objects was introduced in the 1960s in Simula 67, a major revision of Simula I, a programming language designed for discrete event simulation. Created by Ole Johan Dahl and Kristen Nygaard of the Norwegian Computing Center in Oslo, Simula 67 was influenced by SIMSCRIPT and CAR. Tony Hoare's proposed record classes. Simula introduced the notion of classes and instances or objects as part of an explicit programming paradigm. The language also used automatic garbage collection that had been invented earlier for the functional programming language Lisp. Simula was used for physical modeling, such as models to study and improve the movement of ships and their content through cargo ports. The ideas of Simula 67 influenced many later languages, including Smalltalk, derivatives of Lisp, Object Pascal, and C++. The Smalltalk language, which was developed at Xerox PARC in the 1970s, introduced the term object-oriented programming to represent the pervasive use of objects and messages as the basis for computation. Smalltalk creators were influenced by the ideas introduced in Simula 67, but Smalltalk was designed to be a fully dynamic system in which classes could be created and modified dynamically rather than statically as in Simula 67. Smalltalk and with it OOP were introduced to a wider audience by the August 1981 issue of Byte magazine. In the 1970s, Kay's Smalltalk work had influenced the Lisp community to incorporate object-based techniques that were introduced to developers via the Lisp machine. Experimentation with various extensions to Lisp eventually led to the common Lisp object system, which integrates functional programming and object-oriented programming and allows extension via a meta-object protocol. In the 1980s, there were a few attempts to design processor architectures that included hardware support for objects in memory, but these were not successful. Examples include the Intel IAPX 432 and the LinSmart Recursive. In 1985, Bertrand Meyer produced the first design of the Eiffel language. Focused on software quality, Eiffel is among the purely object-oriented languages. but differs in the sense that the language itself is not only a programming language, but a notation supporting the entire software lifecycle. Meyer described the Eiffel software development method, based on a small number of key ideas from software engineering and computer science, in object-oriented software construction. Essential to the quality focus of Eiffel is Meyer's reliability mechanism, design by contract, which is an integral part of both the method and language. Object-oriented programming developed as the dominant programming methodology in the early and mid-1990s when programming languages supporting the techniques became widely available. These included Visual Fox Pro 3.0, C++, and Delphi. Its dominance was further enhanced by the rising popularity of graphical user interfaces, which rely heavily upon object-oriented programming techniques. An example of a closely related dynamic GUI library, a NUP language, can be found in the Cocoa frameworks on Mac OS X, written in Objective-C, an object-oriented, dynamic messaging extension to C based on Smalltalk. UP toolkits also enhanced the popularity of event-driven programming. At ETH Zurich, Nick Lausworth and his colleagues had also been investigating such topics as data abstraction and modular programming. Modula2 included both, and the succeeding design, Oberon, included a distinctive approach to object orientation, classes, and such. Object-oriented features have been added to many previously existing languages, including Ada, Basic, Fortran, Pascal, and COBOL. Adding these features to languages that were not initially designed for them often led to problems with compatibility and maintainability of code. More recently, a number of languages have emerged that are primarily object-oriented, but that are also compatible with procedural methodology. Two such languages are Python and Ruby. Probably the most commercially important recent object-oriented languages are Java, developed by Sun Microsystems, as well as C# and Visual Basic .NET, both designed for Microsoft's .NET platform. Each of these two frameworks shows, in its own way, the benefit of using UP by creating an abstraction from implementation. VB, .NET and C# support cross-language inheritance, allowing classes defined in one language to subclass classes defined in the other language.